our last three-dimensional shape we want to take a look at is a cylinder, or a soda can, or a soup can. We're going to take a look through the same process, edges, vertices, faces. We're going to take a look just at the volume formula, then we'll do a work backwards, and you'll make a net. Well, let's take a look at this. I'm actually going to start with faces. Faces, by definition, are a flat plane that is formed by edges. If I look at this, there are actually no edges. People would say, well, this is an edge. Technically, it's not. An edge is a line segment. And since none of these are line segments, there are no edges. So actually, in edges, I can put a 0. But it's hard for kids to look at this and say there's no flat sides. There are flat sides. The technicality, though, is they're not faces. What these technically are bases. So when you're challenged with how many faces does a cylinder have, cross it off, put the word bases, and know that there are 2 bases. Remember, an edge is a line segment, a straight piece, and there are no straight pieces in this. People would say, what about this? Well, that's only there because that's the visual, the two-dimensional visual. If you turn it, there is no straight piece. Vertices are where edges intersect. Well, if we don't have any edges, it's impossible to have 2 edges intersect. So I end up with 0. How many edges? 0. How many vertices? 0. How many faces? None, but there are bases. So technicality, we need to change. The next part is the volume formula. Volume equals pi, and we remember pi is the number 3.14. You could use the pi button on your calculator, but your answer will be a little different than what mine are. If you use 3.14, it'll be more accurate. Times r to the second. R is radius, halfway distance across a circle, times h. So let's take a look at a cylinder, and somebody asks, what is the volume of it? Here's what I'm going to draw in. I'm going to draw in the diameter is 20, and the height is 7. So I'm going to take my formula and substitute variables. V equals pi, I'm just going to leave it as pi because I know it's 3.14, times r to the second. You cannot put 20 in, and a lot of kids do this. If 20 is the diameter the whole way across, what goes in for r? It must be 10. 10 to the second power times h. h is the height, which is 7. Ready to do my order of operations. I have multiply, exponents multiply. Obviously, exponents has to go first. Pi times 100 times 7. Take your calculator, 3.14 times 100 times 7. Two, 198. This is V, volume. How many little cubes will it take to fit in the object? It's not squares, it's not surface area. So my label is cubes. Cubic feet, cubic inches, cubic yards, doesn't matter. Very straightforward volume formula. Must remember pi is 3.14. R is halfway across, so pay attention. You don't get the diameter accidentally in there. And that is volume. Let's take a look at making a net for a cylinder. When you have to decide what kind of individual shapes it takes to make this, it's pretty simple to see that there's a circle on top and a circle on the bottom, and that the circles should be the same size. They should be congruent. Now, when you go to make a net for me in class, in order to make everybody's circles congruent, we're going to use these colored chips. They're in a pretzel container over in the side cubby. Chip looks like this, yellow on one side, red on the other. So this is what you'll trace on your paper. trace it again, so those are the top and the bottom, the two circles. What a lot of people make a mistake with is what's the inside shape. There's a circle up top, circle on the bottom. I'm going to play this short video and it shows you what does the middle end up being. So when you take the cylinder and roll it out, you end up with a rectangle. Circle up top, a rectangle in the middle, and a circle on the bottom. That's the net of a cylinder. So your job is to make a cylinder net, again, with the chip as your circles, and then you have to decide how big your rectangle needs to be. Again, we will have a work backwards problem. Write down work backwards, and what we're going to do is use the formula, substitute in what we know, use our algebra to solve for what we don't know. Remember, adding opposites gets rid of added numbers, multiplying by reciprocals gets rid of multiplied numbers, and the new one, square root, gets rid of something to the second power. So I'm going to take this cylinder, volume already has been calculated, 904.32 cubes. The height is listed as 8. We want to know what is the radius. So I'm going to take my volume formula, V equals pi times r to the second times h. That's my general volume formula. I'm ready to substitute things in, I know. If you want to put 3.14 in, you can. Times r. I do not know what r is. R to the second. Times h. H is 8. Make sure I'm doing everything the way I want to. Okay. I do know the volume, which is 904.32. 904.32. So what I want to do is try to combine terms. Can I take anything on this side and shrink it down? I think I can. 904.32 equals 3.14 times 8. I can combine 3.14 times 8. And yes, you should use 3.14, or else it's not going to work out exactly the same. 25.12. I still have r squared. R squared. Now, we have not gone over this yet, but now's a good time. Good time as any. How do I get rid of a decimal? Some kids will try to put the reciprocal 1 over 25.12. Well, that doesn't really work so good, because first of all, you can't type it in. The second option is I can make this into a mixed number. That would be 25 and 1200ths, or 25 and 6/50ths. You might not have a calculator big enough to calculate the reciprocal of this. You can do it 50 times 25 plus 6, multiply that to both sides. You can do that. The reciprocal would be 50 times 25 equals 1250 plus 6. The reciprocal would be 1256 over 50, so you could multiply both sides by 50 over 1256. That will work the same, but it may not work. Your calculator might not be big enough. So what if we do this? What if I get rid of the decimal? What if I make it a whole number, which is something we're used to? You can change this to a whole number. The question is, what calculation would I have to do? If I want to make this a whole number, I need the decimal to move right twice. What would you multiply by to move the decimal to the right 2 times? You could multiply by 100. And if in algebra, if you do it to the right side, you must do it to the left. 25.12 times 100 is 2512 times r to the second. Multiply this by 100 is 90432. Now I have all whole numbers. Much better. Okay, now what is the reciprocal of 2512? That's easier for us to process. And it's a little less complicated than making a mixed number. What is the reciprocal of the mixed number? Times 1 over 2512. Times 1 over 2512. The 2512s cancel out. I am left with r to the second, and I got to calculate this side. So 90432 times 1 over 2512 equals, and I end up with 36. Now again, a lot of kids are going straight from here to the answer. Oh, I know what this has to be. It has to be 6. But you must show your algebra of how you got there. How do I get rid of a square? How do I get rid of an exponent of 2? Algebraically, or using algebra, you must square root. And yes, the square root goes over top of it. What is the square root of r squared? Answer is r. If you square root one side, what must you do to the other? Square root. Square root of 36 is 6. So what you found out is this. The radius is equal to 6. So the working backwards, again, substitute in what you know, combine. Now, you don't have to do the times 100. It does get rid of the decimals though. And real quick, why did I choose 100? Because it's got 2 zeros. How many decimal places did I have after the decimal? 2. If there were 3, what number would I have multiplied by? 1,000. If there was 1, what number would I have multiplied by? 10. Please check your answers after you do this work. Make sure your answers look the same as the answer key. Good luck.